Welcome to The Explainer. Today, we're diving into something we all experience every single moment but can't really touch or see, our sense of time.
You know this feeling, right? We've all been there. Our personal experience of time can feel, well, kind of stretchy and unreliable. So how do we even begin to make sense of it?
I mean, whether you're just staring at that pot of water waiting for it to boil, or you're completely lost in a great conversation, the experience of time is totally different. It turns out our brain is the organ that's actually sensing time, and let's just say it's not the most consistent timekeeper on its own. It definitely needs some help to get objective.
So, if our internal feeling of time is so all over the place, how in the world do we measure it accurately? Well, our brain needs to find a steady rhythm, some kind of constant beat in all the noise of daily life. And that's really the key. To measure anything at all, you need something consistent to count against. For time, that means finding something that happens over and over and over again. You know, like a metronome. And this is just brilliant. It turns out our first, most personal clock, long before we had watches or anything, was right there inside us. Our brain had this constant, reliable beat to work with, our own heartbeat. It's kind of like our built-in metronome for experiencing the world.
Okay, so we have this intuitive, built-in clock. But how do we go from just a feeling to a real formal system of measurement? To talk about time like a scientist, we're going to need two key ingredients.
So, first, we've got to understand what we're even measuring. Time is what we call a physical quantity, which is just a fancy way of saying it's a real, measurable property of the universe, just like lengths or weight. The very first part of any measurement is its magnitude. The easiest way to think about this is it's the how much. It's the sheer scale of the thing. It's the number part of the equation. But a number all by itself is pretty meaningless, right? Is it 5? What, 5 feet? 5 pounds? 5 years? That is where the second part is absolutely crucial, the unit. The unit is what gives the magnitude all of its context and its meaning.
And this brings us right back to where we started. The internationally agreed upon unit for time is the second. And it is no coincidence at all that 1 second lasts about as long as a resting human heartbeat. Our own biology became the standard for the entire world. How cool is that?
So we've got our unit, the second. Awesome. But what happens when we start measuring bigger chunks of time, like whole days or years? The numbers get huge, and they get huge fast. And this is where the idea of magnitude becomes so incredibly powerful. Just take one single day. It has 86,400 seconds in it. Now, that's a very precise number, but it's not super easy to work with, is it? It's kind of hard to hold that in your head. So yeah, how do we make this giant number easier to handle? Well, we can simplify it by looking at its order of magnitude, which is basically just a shortcut for saying how many digits it has. It's a way to capture the scale of the number without getting lost in all the little details.
And here it is. That huge number boils down to just 4.9. That's the day's magnitude. It's calculated using something called a logarithmic scale, which basically tells us that 86,400 is almost 10 to the power of 5. It's just a really clean, elegant way to talk about the size of a day.
And we can do the exact same thing for a year. A year has over 31 million seconds, which gives it a magnitude of 7.5. All of a sudden, these massive stretches of time become these simple, manageable numbers that we can actually compare.
Okay, now this is where the system gets really, really clever. Once you have these simple magnitude numbers, converting between different units, like, say, from years to days, becomes just simple subtraction. Get this. You take the magnitude of a year, which is 7.5, and you subtract the magnitude of a day, 4.9. The answer you get is 2.6. And guess what? That's the magnitude of a year when you measure it in days. This little bit of math confirms that a year is about 365 days. It's an amazing shortcut. So we have this incredible system for measuring time, from the tiniest little fractions all the way up to massive spans. But what part of that giant scale can we as humans actually experience? This slide really lays it all out for us. Our direct, sensory experience of time goes from something incredibly fast, like the blink of an eye, which has a magnitude of -1, all the way up to a century, with a magnitude of 9.5. This range, this is our playground. So here's the big takeaway. Our entire lived experience of time, everything we can personally feel, from a lightning-fast reflex to a long life, it all fits neatly between these two numbers.
But of course, the universe doesn't just stop at the boundaries of our senses. What about all the things that are way too fast or way too slow for us to even notice?
And this is the absolute beauty of measurement. Just because we can't feel a microsecond or we can't directly perceive the slow crawl of geologic time doesn't mean they aren't real. Measurement is the amazing tool that lets our senses reach beyond their natural limits. So our ability to feel time has a clear starting line and a clear finish line. But our ability to measure it, that's nearly limitless. It lets us see the invisible and understand the truly immense. It really makes you wonder, what other parts of our reality are out there just waiting for us to find a way to measure them?